You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Okay. And so today, Charles Humble is in the house. Hey, Charles.
Hey, Alex. How you doing?
We're talking about climate. We're talking about sustainability. We're going to talk a little bit about AI. I'm not a big fan of the word sustainability. I'll just tell you that, Charles, right now. I think it's overused. So I've been trying to avoid using the word. So just, I always want to give you a heads up on that. You okay with that?
Okay. Totally.
Right, good.
Yep.
All right, good. Charles Humble, editor and an engineer, as I understand, by trade, right?
Yep.
Tell us a little about what you're up to, Charles.
So I've been in the industry one way or another for about 30 years. So as you say, I was an engineer and an architect and a CTO. And about 10 years ago, I shifted from predominantly writing code to predominantly writing about code, I suppose. It's the easiest way to put it. So I was Infocus chief editor for about 6 years. And then I joined a cloud consulting firm called Conissaunce Ltd. And I was there for about 3 years, just under, I think. And I'm now freelancing, but doing a lot of the same sort of stuff. So it's a certain amount of, startup advisory type work and quite a lot of writing, including primarily for the New Stack, actually, and for some other publications, and doing bits of podcasting and conference speaking and all of that sort of thing. But yeah, my background is all pretty technical.
Why did you decide to make that shift from coding to writing?
Oh, that's a really good question. I think, I'd written professionally for a long time. I'd written code professionally for a long time, for about 20 years, I guess. And I think I got to the point where I wasn't really enjoying programming anymore. I still found computers interesting and I still found the industry fascinating, but I think writing code day to day wasn't exciting to me. And I kind of I'd done a startup which had got acquired, and then I'd had to spend a year working for a very large company that had done the acquisition. And I think at the end of that process, I really just wanted to do something else. But I still love the industry. I'm still excited by, computers and software and what this stuff can do for us. So I think for me, it was a case of I still want to be in the industry, but I just want a bit of a different focus. And I also quite like the idea of, encouraging the next generation of programmers to go in and learn about this industry, because I think the industry is really cool and really fun. And I just felt I could do that maybe more effectively, as I say, by writing and editing and encouraging people that way.
That's really cool. That's really cool. I love that. I love to meet engineers who love to write, because they share such deep perspectives that that they can bring from their experiences. And I know that the topic of sustainability is something that you're really feeling important to discuss.
Yep.
I want to ask you why it's relevant to IT. Why? Because sustainability, as I mentioned, is a term I think is overused. It's used a lot in the tech press, but it's hard to get down to really what it really means for people. I mean, we read headlines about climate. We read, you can look at the data, and it's pretty extreme. But,
it is.
But what is it that you feel is compelling about this story?
So I think there are sort of two ways to look at that. One is a sort of general thing, and then the second is a more technology specific thing. So the general thing is, I actually think there are grounds to be cautiously optimistic. When I was growing up and learning about climate change in the sort of 80s and 90s, it seemed an absolutely intractable problem. It seemed like one of those things where you could never solve it. And even if you could solve it in theory, you'd then have to get all the countries in the world to agree. And obviously that's never going to happen. And I was honestly pretty depressed about it for a long time. And then it turns out that I was wrong. So, the number one climate related concern when I was growing up was acid rain, right? Which is caused by sulfur dioxide, which is a gas that's produced when we burn coal. It has terrible effects on ecosystems. It dissolves old sculptures, it strips forests of their leaves, it leaches soils of their nutrients, it pollutes rivers and lakes. It's very, very bad. It also pays no attention to borders. So, emissions from the US would blow over to Canada, emissions from the UK, where I'm from, would blow over to places like Sweden and Norway and cause major diplomatic instances. And we don't talk about it anymore. And the reason we don't talk about it anymore is because we solved it. So government officials signed international agreements which placed emission limits on power plants and started to reduce coal burning. Those interventions were incredibly effective. And in Europe, sulfur dioxide emissions fell by about 84%. In the US, it was about 90%. And some countries have reduced them by about 98%. And it turns out that, that problem has gone away. We actually, and I was really surprised to discover this, but we actually did something similar with the ozone hole. So we signed the Montreal Protocol in 1987, I think, and that reduced the emissions of ozone-depleting substances by 99%. It's interesting because you were talking about the fact that the news, the press on this tends to be negative, and I think that's true, and I think it's unhelpful. I don't think we talk about our successes enough. The thing with acid rain was the cost of installing scrubbers was significant, but it wasn't, budget breaking. It was a thing that you could afford to do. And similarly with the current challenge we're facing is essentially it's carbon in the atmosphere. There are a few other gases as well, but carbon is the key one. And low carbon technologies used to be incredibly expensive. But again, in the last decade, the price of solar energy has fallen hugely by about 90%. The price of wind energy has fallen by about 70%. Battery costs have fallen, which is why things like electric vehicles are, economically viable now. So there are reasons, I think, to think that we as a species, that humanity as a species could solve this problem if it chooses to. The second thing is that as an industry, we're a major contributor to the problem. So it is the case that since 2010, emissions from data centers and network traffic have grown more modestly than you might imagine if you've not looked at the data, but they have grown. And data centers remain huge consumers of electricity. So global data center electricity use in 2021 was about 220 to 320 terawatt hours, depending on which estimate you use. If you factor in data transmission for networks, which I think you should, because a data center is not much use if you can't get stuff to and from it, then that's another 260 terawatt hours on top. So that's about 580 terawatts in total, I think, if I've done the maths right. So for context, that the upper estimate there is about the same as a country like Brazil. So our industry's electricity consumption is similar to the entire of Brazil. It's far larger than the UK, which was about 331 terawatts the same period. And that's a problem. And I think as an industry, we've kind of got away with it to a large extent for a long time because, we're not a poster child for climate change in the way that, say, aviation is or farming is. But I think that's going to change. And also, I think as an industry, another reason why I think we need to do our bit is because it's relatively easy, right? Most of our problems are problems that we already know how to solve, while as for a sector like, say, farming, that's not true, right? We need new technologies to be developed for farming to become more sustainable, more environmentally sustainable. And so anything that we can do in the tech industry buys us time to work on the more difficult problems. And so, for all of those reasons, I think it's important that we focus. And I worry that with the rise, particularly of generative AI and some of these new technologies, which in many ways are very interesting and potentially very exciting, but I don't think there's enough attention being paid to the environmental costs of those.
I would have to agree with what you say about the overwhelming interest in AI and the ignorance of the paradox that AI poses. For though we have made lots of progress, scarcity is becoming an issue when it comes to water and increasingly when it comes even to electricity. And this to me seems like a big problem. I'd like to get back to that in just a little bit because there's some other follow-up questions that I have that you pose, in particular about generative AI and the impact that it does have on climate change. So you talk about generative AI, and this is a topic that I've been very interested in. And I looked at it from the perspective of the GPU rich and the GPU poor, because I thought that might be a good hook. And as we well know, the GPU is really used quite a bit in data centers now to run enterprise applications that integrate machine learning and AI. But NVIDIA controls pretty much 95% of the chips, and so they're really the only place you can go for GPUs. And so that leaves most everyone else as GPU poor. Only the very wealthy can, the very wealthy companies can afford to like buy them en masse. Pretty much because there's just such high demand. Now there's companies like Databricks out there who will tell you that, well, we think that the cost is actually going to go down over time and that this will even out. But there's another problem too, and I think that comes down to what you're talking about, because at some point the water and electricity demands become the focal issue. And that's something that we're starting to see. And we're starting to see it in Chile, for example. They partially reversed a permit for a huge Google data center. We're seeing it in different parts of the world. There have been some cases where local markets have put a moratorium on data center development. Those places include Hong Kong and Frankfurt and the Netherlands. And the electricity that these chips use is tremendous, and the actual foundries themselves, the way they make these processes, the amount of energy is just tremendous. And so that seems to be the new challenge, out there. And why does this matter to IT? Like, why does this matter to the company that's like being pressured to put AI features into their applications and everything else?
Well, I think there's several answers to that. I think broadly speaking, building software in a more sustainable way has some tangible business benefits. One of which is that it saves you money. So if you think about cloud bills, for example, Gartner has estimated that 70% roughly of cloud bills is essentially wasted money. I think it's also the case that it can help with security. So if you have machines running in your own data centers that aren't being used anymore, that's still running, they still represent a security risk. So, there are immediately tangible benefits, even if you ignore the having a habitable planet to live on is in and of itself a good thing. I think one of the challenges around AI in particular is there's really very little information available to us at the moment. We don't really know. OpenAI's GPT-4 white paper provides almost no information on architecture or model size or hardware or anything. Its GPT-3 paper does note that practical large-scale pre-training requires large amounts of computation, which is no great surprise and is very energy intensive. There are a few figures there. There are some estimates kicking around. There's one from a research paper from about 2021, I think it was, that said that GPT-3 would have used about 1,287 gigawatt hours and generated about 510 tons of carbon. So that's about the same as 120 years worth of a single US family's electricity use, more or less. Some estimates have put it considerably higher. So I think one thing there is there needs to be pressure applied to companies to make this information more, in the public domain so that we know what's going on. There are some signs of progress. So Meta, when it was developing APT175B, was talking about energy efficiency in their paper. And they said that their model, which is about the same size as GPT-3, was trained using only about 1/7 of the carbon footprint. But I think it's one of those things, I think it's going to require legislative pressure. And I think it's also going to require pressure from consumers. It's worth saying too that for training specifically, that stuff is not particularly latency sensitive. So you do have the option of training in, regions where the electricity use the electricity that's available to you is greener. i.e. is coming from renewable sources or nuclear or something like that, which is obviously a better thing. It's probably also the case that the electricity consumption of running these models is worse than the training cost. So
Yeah.
again, you come back to where you're hosting these things really matters. You also brought up water consumption. And again, that I think is a huge problem. But I haven't seen, I'd be very interested to, I know you're doing some research on this, I'd actually be very interested to read it. Because apart from the odd thing in some of the scientific press, Nature and things like that, I've actually not seen that much around the the water use. But again, I think it is a huge problem. It's just not something that we've maybe quite got to talking about yet.
Right. Yeah, it is something we haven't quite talked about yet. I think one thing I've tried to figure out is if you look at the processes themselves and the chips themselves, what are their energy requirements, and then you start to multiply that out, you start to see some patterns, and and the amount of electricity that a standard chip produces compared to what an AI chip produces is much different. Now,
Mhm.
there it can vary according to all kinds of factors, as we well know. But if you look at, for instance, Intel is building is announced last week that they're getting into the foundry business.
Yeah.
They announced Microsoft as a customer for the Intel 18A process. And this is the process that will be used according to reports in the new Maya 100 AI accelerator and the Cobalt 100 CPU, and these are both from Microsoft. These are their new custom chips.
Mm-hmm.
And if you start to look, you start to put together the pieces, you start to see some things. You start to see OpenAI CEO Sam Altman, who appeared at Direct Connect. With Pat Gelsinger on stage. Pat Gelsinger, the CEO of Intel. Altman has talked a lot about the demand for AI chips, and he's talked about this issue. I was actually looking at your container solutions report, and like the amount of coal burning that's done in, for instance, different parts of the world in Asia is significant. So that speaks to electricity. The water shortage, we're starting to see the impacts of that in places like Taiwan, where there have been droughts, and where water has actually been, so scarce that there have been choices that have had to be made between like providing farmers with water for irrigation or for the semiconductor foundries.
Mm-hmm.
So the problem is deep. But if you look at kind of like the process that you need to make these chips, and you start looking at the chips themselves, and how hot these chips get, this is where you start to learn a little bit more. So, for instance, there's two real factors here. There's the cooling factor, and there's just the amount of water that you need to build chips with extra pure water, right? That's what they need. They need that extra pure water. But if you start looking at it and from that perspective, you start to see some patterns. But here's the paradox for me is like these companies are all in. They want to build foundries all over the world. And AI is just becoming so widely used so fast that, I just wonder what it is that, that is going to turn the tide. And I think what you're saying is pressure.
I think so. Yeah, I think it's a mixture of things. I think you have to get to a point where you have carbon-free electricity in data centers. So basically all electricity use in data centers is time matched with green grid power. So the idea there is that for every watt of power used by a data center, there's a renewable watt of power going into the local grid. It's complicated, but that's the sort of summary version of it. And that means you don't need storage. It's hard to do. So Google were carbon neutral in 2007, and they don't think they'll get to 24/7 carbon-free electricity before about 2030, but it is doable. So I think, at a high level, I think decarbonising the grid is one way to go.
Yeah.
Now, there are tools like Electricity Mapper that you can use now that give you a pretty good idea of what the renewable versus non-renewable energy sources are. So when you're thinking about where you're locating your data centers, or if you're using public cloud where you're hosting, that's a good thing. There's also a thing around end user devices. So the EU has this idea of a 10-year life expectancy for end user devices. And the reason for that is because for end user devices, the embodied carbon, that's to say the carbon that's emitted during the production or disposal of the device, completely swamps the carbon that's emitted when you're charging them or powering them during their lifetimes. So for data centers, it's all about the electricity used to power the data center. And for end user devices, it's all about basically extending lifespan. So making sure that when you issue mobile operating system updates for your phone or something, you don't slow the device down, making sure you've got security patches, manufacturing them in such a way that they last for a long time. I think personally that in order to get companies to do the right thing, we will probably end up needing legislation. We'll probably end up needing some form of carbon tax. Not everyone would agree, but that is my view. Again, the EU has what they call the Carbon Border Adjustment Mechanism, or CBAM, which basically aims to make everyone who supplies to the EU green. And they say that within the EU, within 9 years, CBAM will cover all goods and services coming into the EU, and that'll obviously include the IT industry. So if you want to do business with the EU, you will either be paying a carbon tax, which could get quite high, or you will be green in some way. Obviously, that's only the EU, but I think it might be like the GDPR legislation, the European Data Protection legislation, where I think other countries might well end up following the EU's lead. So I think, as I say, I think legislation is probably a part of this. But I also think, I hope that there is a sort of desire to do the right thing, whether that's financial incentives or whether that's just a recognition that we can't pretend that this problem is just magically going to be solved for us. I'd like to think that we would, as an industry, would start to take this stuff seriously. And I think, if you're using products from OpenAI or from, AI products from Google or whatever it is, you absolutely have the right to go to them and ask them, tell me about your climate story, tell me about your carbon story, and put pressure on them that way. In the same way that we did, like AWS, one of the reasons AWS made climate part of their architecture patterns, part of their sort of central pillars, was because customers were asking them for it. So I think there's a lot to be said actually for just demanding that these companies start doing the right thing, possibly back legislation.
I think it does come down to it does come down to the policymakers. Your examples of acid rain and such are excellent references. Question I have for you is, those little things that we hear about, like does code efficiency, and and thinking about what programming languages you use, does it have any place in this? Is that anywhere? Is that a start at all?
Oh, that's a great question. I think everyone that works in software automatically thinks the thing to do is to rewrite all of my software in Rust or C or assembly language or something, because it'll be more efficient. And it will make a difference. So, Python is about 100 times slower than C is, for example. So what that means is that Python uses about 100 CPU operations more than C does to do the same work. 100 times improvement sounds really good. But there's a reason we mostly have moved away from languages like C or even Rust or assembly code or whatever, which is that there's a compromise between machine efficiency and developer productivity. So typically higher level languages tend to be more productive from a developer point of view, but less so for machines. So there are a couple of things there. One thing with coding efficiency is it's really important to measure, because it's one of those things where your assumptions will often mislead you. And as an example, people tend to think that Java's maybe very slow and inefficient, and it's memory expensive. But actually, it turns out if you benchmark it, it's surprisingly good. The hotspot JVM does amazing work in terms of inlining and code efficiency on the hardware it runs on. I also would have assumed that the Graal VM, which is essentially Java compiled to run natively, would always win over bytecode Java. But it turns out when I measured that, that wasn't true. And I measured it a few times, so I was sure I must be measuring it wrong, and it persisted in not being true. Sometimes it's better, but it isn't always. So I think measuring these things is probably, it is always a good idea. But honestly, most of us, there are probably easier wins. I've mentioned a few times hosting location. You know, if you're hosting in a location that mostly uses renewable energy, then you're already far better than if you're hosting all of your stuff in, I don't know, Virginia or somewhere that's a coal-fired state. If you're doing things like turning off computers that you don't use, which sounds kind of crazy, we don't, right? We really don't. Holly Cummings from Red Hat has this wonderful thing. She talks about light switch ops, which I really like as an expression, which is this idea that, you know, you should be able to turn a server off and on again as easily as if you could turn a light switch off. Thinking about your servers as ephemeral, if you will. And I think, you know, even if you were just turning off your test instances at evenings and weekends, it would make a difference. Right sizing your environment. You know, if you have the hardware you need but no more, then that's probably going to do more to return for you than coding efficiency. And actually, if you do all this work to rewrite your code and then you don't bother to right size your environment, you've probably not gained very much at all, I would think. So we may well get there. We may well get to a point where coding efficiency and the language choices we make and those kind of things make a huge difference. But I think most of us are probably so far away from that being the thing we need to do first. I think a lot of progress is made in ops. I think if you, as I say, if you right size your environments, if you get rid of stuff you're not using, you know, aim to cut your hosting bill in half, which sounds like a hugely ambitious goal, but probably isn't. It's easy to get your business behind something like that because it's saving money, and which business wouldn't want to do that? And it's easy to measure. And it turns out that that's quite a good proxy for your electricity consumption. So just as a quick example, VMware it was a data center in Singapore that they were moving, and in the process of moving, they did an audit of all of their computers and discovered that they could turn off 66% of them, 66%, because they weren't really doing anything. And I suspect a lot of people are in a similar boat. I think if we actually spent some time auditing what our hardware was doing, we would find there was an awful lot of it we probably didn't need anymore. So I would start there, basically, and get to things like coding efficiency when you've got the scale where it matters. Maybe when, if your application is in steady state, then that kind of optimization makes more sense. So in other words, if you're not developing if you're not constantly adding new features to an app, then thinking about optimizing it at that point probably makes more sense. But I suspect we might never need to get there. I suspect if we did all the ops stuff, we might find that we'd done enough, which would be nice.
There's a sort of madness that overtakes people, isn't it, when new things come along and people begin to think that they're really needing to do things. Are there priorities that you see software engineers need to make when they're thinking about new features, for example, that might consume more energy than they really need to? So those are the kind of things like you were talking about with hosting, for example, that affects your profits.
Yes, I mean, I think with any feature that's substantial, with anything you're developing, it's a really good idea to ask the question, you know, why are we building this? Is this relevant? Do we really need this thing? And I think, I mean, I suspect no one is here yet, but I think there would be benefits in having some carbon cost or some cost metric that is a metric that you're measuring as you're building. So rather like you would have, you know, on your dashboard, you would have other performance metrics. Basically, how is my system running? Electricity consumption or hosting cost or something being something that you measure and keep an eye on, so that if you put something into production and it makes everything worse, you actually know that, rather than having to go and fit it in retrospect. But I absolutely think, when we're thinking about these features, we should be weighing up carbon cost against usefulness. And in the case of something like generative AI, that's quite an interesting, that would be quite a difficult calculation to make, I think. Is it going to be cheaper to, have a chatbot answering questions or have a human answering questions? I think that calculation might come out differently if you factor in the carbon cost versus if you don't. I don't know that for sure. But yeah, I absolutely think it's stuff that we should be thinking about and factoring in. So yeah, I absolutely do. I absolutely do.
That also affects a lot of things, like developer experience, right? I mean, like if you're building out new features for AI and you're not really sure if they're needed, you're just building them out. Like I've heard one company talk about how they're, they had an advertisement on a public radio station here, like they are AI from their core, and
Right.
this is a company that's been around like for decades. Okay. So like in the span of a year, now AI is at their core. That just to me seems absurd. And so, it leads me to, this question I think that I have is about, how do companies just think about slowing down? Yeah. And that just seems very difficult for a software engineer to face. Like if they have marketers and the CEO and CTO saying we need AI right now. And so I'm just curious on what are some approaches, that people might.
It's really difficult, I think. I mean, I genuinely think it's difficult, and we've been through a few of these in the industry, and the time that I've been involved in it. The whole shift to microservices and distributed architecture. A lot of that was driven by, CXOs reading about microservices and saying we want to be more like Netflix. And when you actually sat down and said, well, why do we want to be more like Netflix? A lot of the time, people weren't that sure what the answers were. Most of these things have trade-offs. So if you think of microservices allow you to build software faster, but they do that and they allow you to scale horizontally really well. But they do that at a cost of operational complexity, essentially. So monitoring is harder. When systems break, it's harder to work out why. I think a lot of the time, having conversations, I think when you're in a position where you have influence at an exec level, like if you're a senior developer or something like that, but maybe not the CTO, I think one of the most important things to do is to be constantly trying to make your argument in terms that make sense to the business. I think very often, I've had conversations with people in my consulting work where, like, I'm telling the business I need to pay down technical debt, and they're not listening to me. And why are they not listening to me? And you're like, well, have you explained to them what that even means? Because I think we assume that the business knows what technical debt is, but maybe they don't. And I think with something like AI, having a serious conversation about, well, what are some of the risks? What are some of the benefits? What business problems are we really solving? I think, a lot of the time, a lot of this technology is very new and very poorly understood. The use cases are not well understood, and it may turn out that there are some really good use cases. It may turn out that there aren't. Like 2 years ago, everyone thought blockchain was going to change the world, and now I think most people would say, again, distributed ledgers have their place, but the impact was smaller than we thought it would be, maybe. And that may well turn out to be true of AI as well. My own view is there will definitely be places where this technology is useful. Yes. I think it's also massively, massively overhyped at the moment. And I suspect that those use cases are going to be much smaller and much more contained. And don't forget, they're a huge risk. If you replace all your call center people with chatbots or something, and then the chatbots start making stuff up, as I think it was Air Canada discovered quite recently, this is a problem. You can get sued for that stuff. So I think, as I say, think about how you put things in terms that make sense to the business is maybe the answer there. And I think that's true for anything in IT. I think in general, as IT professionals, this is something that we need to make sure that we're doing and thinking about is, how do I communicate this stuff to the business in a way that makes sense to the business, whatever it is.
Maybe in conclusion, we provide people with some resources too. I have one that I'd like to share. So power hungry processing and what's driving the cost of AI deployment. And one of the interesting kind of like effects, I think, of this AI race is that people are thinking about, how can I be more efficient, right? Like you're talking about. I think this is something that would be wonderful to people to talk more about. How can you just be more efficient, right? What are the trade-offs you're making, like the things you're talking about? And this is, to me, be a good resource for people who are interested in this topic, because it looks at the, what is the cost of model deployments and how do you compare those costs of model deployments? So that's my resource. What are some of the resources that you see that people could use?
Yeah, so there are some quite good books around. A couple of general sort of climate change related books. One is the Bill Gates book, so How to Avoid a Climate Disaster, which I think is very, very good indeed. There's a book by somebody called Hannah Ritchie called Not the End of the World, which is a sort of more optimistic take on climate change. And I think that's tremendous. I'd really recommend reading that. Anne Curry and I co-wrote the second edition of a book called The Cloud Native Attitude, which I think we mentioned earlier. That's available as a free download from the Container Solutions website, I think. And it includes some case studies and also just a good basic introduction to climate change from a software perspective. The Green Software Foundation has some excellent material. That's like an offshoot of the Linux Foundation. They have an introductory course and an exam for green software practitioners. And then there's a forthcoming book from O'Reilly called Building Green Software, which is with Anne Curry and Sarah Sue and Sarah Bergman. I read an early version of this and it's really, really solid. It's a really good book. It's quite dense. It's quite an intense read, but I would really recommend people get hold of that as well. And then there's one blog from Holly Cunnings called WTF Does Tech Have to Do with the Planet? Great title. And that's really good as well. So yes, those are probably my major suggestions, I think. I should say as well, I think Anne Curry is running a course called Building Green Software on the back of the book, which we could probably share a link to if anyone's interested in having a look at that too.
We should probably get Anne on this show and talk to her.
She's great. You should. You totally should. She's very knowledgeable and she's a great communicator. So yes, for sure.
Well, Charles, thank you so much for your time. I've really enjoyed it. And I look forward to talking more on this topic with you. I think it's quite relevant. I ran into some people at this Intel event, some press and analysts who are saying they were just kind of dejected about, how do you write about this stuff and make it compelling? But it becomes compelling when there's interest in it, right? And like when there's interest in it, when people are advocating for what you actually can do. So I appreciate your perspectives. This is really helpful, and I think this story will just get more interesting.
Fantastic, Alex. Thank you so much. It was great fun. I really enjoyed that.
Great. If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.